Solve x squared minus 2y squared equals 1, xy equals 6. We have two equations. Both of them are nonlinear, but this one we can solve for x or y pretty directly. Let's solve for x, and we have x equals 6 over y. Then we can substitute in the first equation. Substituting this for x, we would have x squared, which would be 6 over y squared, minus 2y squared equals 1. This would give us 36 over y squared, that's squaring the numerator and squaring the denominator, minus 2y squared equals 1. And multiplying everything by y squared, we would have 36 minus 2y to the fourth equals y squared. That clears fractions for us. Now let's get everything on one side of the equation and 0 on the other. We'll subtract 36 and add 2y to the fourth to both sides. We have 0 equals 2y to the fourth plus y squared minus 36. Now we could substitute for y squared, make this a u and a u squared substitution, or if we can try to factor directly. We could factor this as 2y squared plus 9 times y squared minus 4. And that gives us two binomials that we can set equal to 0. That by the principle of zero products, this tells us that either 2y squared plus 9 equals 0, or y squared minus 4 equals 0. And this would tell us that y squared equals negative 9 over 2, that's y squared, or y squared equals 4. Now we have to solve for y. And over here, y squared equals 4, taking the square root of both sides, y would equal plus or minus 2. This is a little more complicated because we have a negative number. So our answer is going to be a complex number, an imaginary number. Actually, so we have y equals plus or minus the square root of negative 9 halves, which would be plus or minus I times the square root of 9 halves. Now we don't normally leave it quite like this. We want to rationalize the denominator. If we take the square roots of the numerator and denominator, we have plus or minus I times the square root of 9 is 3 over the square root of 2. And then multiplying numerator and denominator by the square root of 2, we would get plus or minus I times 3 square root of 2 over 2. Now what we have so far are four values for y. Plus or minus I times 3 square root of 2 over 2, which we normally would write the I afterwards, and plus or minus 2. So now we'll take each of those values for y, and we'll substitute in this equation, and we'll find the corresponding values of x. Let's start with y equals 2. When y is 2, x is 6 over 2, or 3. So we have the ordered pair 3, 2. When y is negative 2, x is 6 over negative 2, or negative 3. And that gives us the ordered pair negative 3, negative 2. Now the next two will be a little more complicated to simplify. When y is 3 square root of 2 over 2i, then x will be 6 over 3 square root of 2 over 2i. We simplify, we would divide by this, which would give us 12 over 3 square root of 2i. And 12 divided by 3 is 4, which gives us 4 over square root of 2i. Now we don't want to leave it this way. Let's multiply the numerator and denominator by the square root of 2i. 4 times the square root of 2i over the square root of 2 times the square root of 2 would be 2. I times I would be I squared. Now we're almost done. I squared is -1, so that gives us a negative number in the front, a negative sign, and 4 over 2 is 2. So we have -2 square root of 2i. And that gives us the ordered pair, -2 square root of 2i, 3 square root of 2 over 2i. The last value of y is -3 square root of 2 over 2i. Now if we look through this, we'd find that this will be just like this, only we have a negative sign all the way through, which would change the sign of the answer. So we would just have x equals +2 square root of 2i. So we're all done except for stating our solution. Remember, we found 4 ordered pairs, so we want to give all 4 ordered pairs. The first 2 were 3, 2, and be careful to put the x first, even though we found y first, alphabetical order. 3, 2, and then -3, -2, and then we found the ordered pair -2 square root of 2i, +3 square root of 2 over 2i. And last, we found the ordered pair 2 square root of 2i, -3 square root of 2 over 2i.